Okay, so this is extra practice for Unit 10, Objective 1, and I've grouped these extra practice problems, roughly speaking, according to how you see them in your notes. That way, if you are currently watching through the notes video and maybe you did numbers 1 through 4 and felt like you still weren't good with those and so wanted to do a little bit of extra practice like examples 1 through 4, well, the first 3 problems are going to be like examples 1 through 4. Or if you felt like you were good with those ones and you want to fast forward through this extra practice video to find the particular topics you wanted to practice, you can do so, because again, each of them will be grouped according to how you see them in your notes. Okay? I'm going to walk through all of these though, just kind of one after another. That means that you need to make sure you use this extra practice video how you see would be best for you. I don't believe it really does us a whole lot of good to just watch the problems and not be practicing them on our own, so I would highly recommend pausing the video, doing one, restarting the video, hearing the explanation, or maybe fast forwarding to the answer if you just want to check your answer, whatever you feel like is best for you. And then if you are practicing ones like examples 1 through 4 and you do 2 of them, you're like, okay, I feel like I got it now. Well, you don't have to do the 3rd one if you don't want to. It's there for you to use as you see best for you. Okay? And then as always, if there are any extra problems at the end of this that you would like to have done, or questions that you still don't have answered, reach out to your teacher. We're here to support you, right? Okay, so here we go. First 3, like examples 1 through 4, we've got some coordinate points here, polar coordinate points that we are looking to graph, and that's all we're doing. Okay, so we have first up 3, -195 degrees. Okay, so I'm going to go ahead and give myself a little coordinate axis here. Okay, so radial line. A reminder with your graphing polar coordinate points, it's r theta. So my theta here is -195 degrees. So if I went -195, well, -180 would send me to the other side of my x-axis. -195 is 15 degrees further. So we're looking at something maybe like that. A little bit beyond -180. And then continuing that in the opposite direction. Okay, our r is how far we move along that radial line. A reminder that a negative r sends you away from your angle. Positive r sends you out towards your angle along your radial line there. And so in this case, because we have a positive r, we are going to be moving here in the second quadrant with the -195 degrees. If it was a negative r, I'd be moving into the 4th quadrant with that dotted line. Okay, so we're moving 3 out, which is right there. Okay. Next up, root 2, 5 pi over 4. Okay, so again, r theta. My theta in this case is 5 pi over 4, so where does 5 pi over 4 sit? Okay, well, 5 pi over 4 is the 45-degree angle in that 3rd quadrant. Extending backwards. In this case, we have a positive r, so I am moving out along that radial line, and I'm moving root 2 out. If that was a negative r, I'd be moving the reverse direction, but I am going to end up down here in the 3rd quadrant. Now, root 2, I don't know exactly what root 2 is, okay, but I know what root 1 is. Root 1 is 1. And I know what root 4 is. Root 4 is 2. And root 2 is going to be closer to root 1 than to root 4. So it's going to be closer to 1 than it is to 2, but somewhere between 1 and 2. And so we're looking at, oh, I don't know, about there, roughly speaking. If you took a moment and actually calculated root 2, I believe it's 1.4 if I remember correctly, or somewhere right around 1.4. So again, a little bit less than 1.5, a little closer to 1 than it is to 2. but it's an approximation, doesn't have to be perfect. Okay? And then one more here. Again, make sure you're pausing the videos, trying them on your own. Okay, so last one, we have our negative 3 root 3, which is our r, negative 2 pi over 3, which is our theta. So radial line, where would negative 2 pi over 3 be? Okay, well, negative 2 pi over 3 would be in the third quadrant, because 2 pi over 3 is in the second. So negative 2 pi over 3 would be in the third quadrant. It's a 60-degree angle in the third quadrant. And reverse the opposite direction. Our r in this case is negative, so I'm not actually going to be moving out along this line. I'm going to be moving in the opposite direction, negative 3 root 3 in the opposite direction. And then how much 3 root 3 is, again, we don't know for sure. We know it's more than 3. 3 would be 3 times root 1. So it's more than 3. And we know it's less than 6. 6 would be 3 times 2, or 3 times root 4. And it's closer to 6 than it is to 1, or to 3. So we're looking at probably right around the 5 mark. 1, 2, 3, 4, 5. So we're looking kind of right in this zone. If I remember correctly, I don't think it's actually 5. It's like 5.1 or 5.2, so it's actually a little bit more than 5. But again, it's a rough approximation. So I guess my dot did end up being a little bit above 5, so like right around 5.1. Yeah, okay. Okay, so those are more like examples 1 through 4. Moving on to 5 through 7, again, pause the video, try them on your own. If you felt like you were good with examples 5 through 7, then maybe skip this section, whatever you need, okay? Okay, 5 through 7, we were looking at naming 3 other coordinate points for the given polar coordinates. Okay, so we start with, in this one, negative 3 pi over 2. Okay, so the first thing we'll do is keep the same r and then either add or subtract pi over 2. Now if I add or subtract, let me start over. Backing up, sorry. Okay. First additional coordinate point, we start with the same r, but then we either add or subtract 2 pi to our theta. Now, if I add 2 pi to pi over 2, I end up higher than 2 pi, which is fine unless your restricted domain is between negative 2 pi and 2 pi, which is what it will be on your homework. So we're not going to add 2 pi. We're going to subtract 2 pi. Okay, so pi over 2 minus 2 pi is negative 3 is my radius. Pi over 2 minus 2 pi, common denominator, is pi over 2 minus 4 pi over 2, which is negative 3 pi over 2. Okay. Next additional coordinate point is taking your r, which is negative 3, and multiplying it by a negative. And then your theta plus pi and minus pi for your next 2 points. So starting off, we're going to minus pi. So we have positive 3 pi over 2 minus pi is pi over 2 minus 2 pi over 2, or negative pi over 2. Okay, and then the third one, taking your r, which is our negative 3, multiplying it by a negative, and then your theta, your pi over 2 plus pi. So 3 pi over 2 plus pi over 2 plus 2 pi over 2, which is 3 pi over 2. Okay. Okay, next up, let's separate this. We've got our root 2, 5 pi over 4. So first up, keep your r and take your theta and either add or subtract pi to it. In this case, we're going to subtract 2 pi. If we added 2 pi, it would send me up and over my negative 2 pi to 2 pi domain, so we're going to subtract 2 pi, which is my r of root 2. 5 pi over 4 minus 2 pi is 5 pi over 4 minus 8 pi over 4, which is negative 3 pi over 4. Okay, next up we take our r, multiply it by a negative, our theta, and we subtract pi. So my r is negative root 2. 5 pi over 4 minus 4 pi over 4 is pi over 4. And last but not least, take your r, multiply it by negative, your theta, plus pi. Okay, so that's my negative root 2 there. Well, I just realized this is going to send us up and over 2 pi. So what we're actually going to need to do, it looks like, is take this one and subtract another pi from it. Yeah, take this one and subtract a pi from it. I hadn't caught that when I made my additional answer key. So let me show you my thought process here. I just caught this right now. So it's a good one for us to look at. 5 pi over 4 plus pi is 5 pi over 4 plus 4 pi over 4, which is actually 9 pi over 4. So which is not, it's not like that's not a name for our coordinate point, so it actually would be fine to leave that. But if you had to give a value such that theta was between negative 2 pi and 2 pi, that one's bigger than 2 pi, and so we wouldn't actually be able to use it. So what we would actually want to do is subtract another pi from this guy, or subtract 2 pi from this one, whichever one you prefer, to get you down into below the 2 pi over 4. So I'll go ahead and box that one because it is an answer. But say we wanted to lie in our negative 2 pi to 2 pi range, we would say maybe take this one, our root 2, negative 3 pi over 4, multiply that by a negative, and subtract pi to give us negative root 2, and then 3 pi over 2 minus pi, which is negative 3 pi over 2, minus 4 pi over, sorry, negative 3 pi over 4 minus 4 pi over 4, which is negative 7 pi over 4. And so you could do that if you wanted to, which would be the equivalent of taking this one and subtracting 2 pi from it. Pi over 4 minus 8 pi over 4, which would be negative 7 pi over 4. So, unintentional extra practice there, but a good thing for us to kind of think about. Making sure you are aware if you have a restricted domain that you are watching that. Make sure you stay within negative 2 pi to 2 pi. Okay, and then our last one here, we've got our negative 3 root 3, which is our r, and then negative 2 pi over 3, either plus or minus 2 pi. In this case, we're going to add 2 pi, which is same r, negative 3 root 3, and then negative 2 pi over 3 plus 2 pi is negative 2 pi over 3 plus 6 pi over 3, or 4 pi over 3. Okay, next up, original r times a negative, and then our theta minus pi. Okay, so this would be a positive 3 root 3, and then negative 2 pi over 3 minus 3 pi over 3 is negative 5 pi over 3. And then last one, our original r times a negative, and our theta plus pi is a positive 3 root 3, and then negative 2 pi over 3 plus 3 pi over 3, which is pi over 3.